Hello, in this video I will demonstrate how I configure secure management access and monitoring on a network device. The main goal of this setup is to improve security, centralize authentication, and logging. During this demonstration I will cover 5 main steps: SSH access configuration, user accounts privilege levels, and AAA configuration with TACACS and local fallback, syslog and SNMP configuration, testing and verification.
In this video, I'm going to explain about my part, about network topology, IP addressing, and security mechanisms that I implemented, including port security, including ACL, Cisco iOS firewall, zone-based firewall, and intrusion prevention system. Our network is divided into 3 security zones: inside internal LAN with users, the next is demilitarized zones with servers, and outside zone it is external network with attacker PC. Each zone has different security levels. On screenshots you can see IP addressing table, see configurations for router, for PCs. First security mechanism that I implemented, it is switch port security on the internal LAN switch. Its purpose to protect against layer 2 attacks such as unauthorized device connection and MAC address spoofing. So if a violation occurs, the port is automatically shut down. Let's see on first attack unauthorized device connection. You can see normal condition for port. You can see the security violation count is 0. For instance, imagine that attacker disconnect PC1 and connect another laptop to the same port. And you can see that port is automatically shut down. Second attack is MAC address spoofing attempt. Imagine that attacker learned the MAC address of trusted PC and attempted to connect to the network using the same MAC address. To prevent another PC from connection even with the same MAC address, port authentication is required.
First, I configured SSH access to ensure secure remote management of the device. It's used instead of telnet because it encrypts all communication, including usernames and passwords. This prevents credential interception and man-in-the-middle attacks. I generated RSA keys and configured the domain name. After that, remote access to the device is allowed only through SSH. Next, I created local user accounts with different privilege levels. This allows role-based access control, where regular users have limited permissions, administrators have full access, and using privilege levels helps reduce the risk of accidental or unauthorized configuration changes. Here you can see the demonstration.
Next, I configured extended access control list. The ACL were used to control traffic between networks. From inside to DMZ, only HTTP, HTTPS, and ICMP are allowed, and from outside to inside, all traffic is blocked. So this ensures that internal users can access the web server in the DMZ, while attackers from the external network cannot reach the internal LAN. So let's verify. Ping from attacker PC to LAN should be blocked. So it's blocked. Ping ICMP from LAN to DMZ should work. It works. And access to web server through HTTP and HTTPS from LAN should work. So it works.
Next is AAA. AAA configuration with TACACS. AAA allows authentication is handled by a centralized server. User actions can be tracked, and access control is more flexible and secure. I also configured local back authentication as a fallback. TACACS is a network protocol providing centralized AAA for controlling users' access to network devices like routers and switches.
Next part about firewall. So first I configured Cisco iOS firewall. You can see commands that were used. TCP will verify HTTP and HTTPS connections, and ICMP allow pings for diagnostics. To avoid some conflicts before continuing the configuration for zone-based firewall, I disconnected ACL and Cisco iOS firewall from interfaces. I created inside, outside, and DMZ zone. So let's check the traffic from user PC1 to web server by ICMP. Next, I need to check traffic from user PC1 to web server by HTTP. Traffic from the external network outside to the DMZ is allowed only for HTTP. All other traffic, including ICMP, is blocked. From attacker PC to DMZ web server by HTTP. From attacker PC to inside zone. Traffic from inside to outside is allowed.
And next, SNMP configuration allows network monitoring, device status tracking, and alerting. These tools help administrators quickly detect errors, security events. It works by exchanging data between a central SNMP manager and software agents on managed devices, and to collect data like traffic, error, and speed.
Next, I enabled a configured IPS. Now I'm going to show you attacks, ping flood, and port scan. First, before the attack, I disabled ZPF on interfaces to demonstrate ICMP requests. So goal of the attack, overload a network device with many ICMP requests. From attacker PC, I did many ping to web server about 15-20 times, very fast. It's like simulation ping flooding. After many requests, you can see that request time out, packet loss, no stable responses. This shows that packets are starting to get lost. It is IPS prevention. The next attack is port scan. Port scan is when attacker doesn't hack the system but gathers information. For instance, which ports are open, which services are running, like HTTP, HTTPS, and SSH. So first I need to enable ZPF again. Then I need to check ping to web server from attacker PC. It's blocked because from outside to DMZ, ICMP port close, filtered. Then I need to check HTTP from attacker PC and HTTPS. And you can see that ports are open. Then I repeated many times ping, refreshed HTTPS, again ping, again HTTP. This simulates checking port one by one, similar to a port scan. IPS prevention is demonstrated through traffic behavior. When an attack is detected, malicious traffic is dropped and doesn't reach the destination. This behavior confirms successful prevention.